Hi everyone, hope you're doing well. In this video we are going to discuss about the system design of a chatting application that I'm currently working on. I thought it's pretty cool to share what is the system design that I thought while I was building the application. The main concept that I had in my mind while I was designing the application was scalability. Okay, so let's see how well I did with this. Okay. So now getting into the system design, so this is the design. This is the actual design that I'm using right now. So by seeing this, I think you can understand quite a bit, but I'll try to explain bits and pieces. Okay, so I'm going to explain how the text messaging. Okay, how the text messaging actually work. How the messages get transferred from a client A to client B. Okay, so let's say this is a setup where there are two clients, client A and client B. They want to talk to each other, so they will connect to the server. So let's say when they open the application and connect to the server, okay, a WebSocket connection will be opened between client A and let's say server. So let's say the WebSocket connection name is W1, and when B connects, it will also open a connection. Let's say the connection name is W2. Okay. Now what happens is when they connect to the database, when they connect to the server, a queue is created. It is a RabbitMQ queue. Okay, but you can use Kafka. And there are some other message brokers, so you can use them also. You can use Redis too. Okay, so I'm using RabbitMQ. So a respective queue will be created per client. Okay, so let's say for when client A connects to the server, this queue is created whose name is whose name is A, or for reference for right now, let's say its name is A, and when client when client B connects, so it also creates a respective queue. Its name is, let's say, queue B. Okay, so what happens is let's say when A wants to send a message to client B. Okay, so now what happens is, let's say client A wants to send a message to client B. What will happen? It will not send the message directly to client B through this WebSocket connection. This WebSocket connection is just is for another reason. Okay, I'll explain that later on. So what it is doing it. So first let me explain this thing. Like this queue. Why I have designed this queue, or what is the use of this queue? So this queue is used as a event listener or a receiver of all the messages that a particular client will have. So let's say this is a queue A which is associated with this client A. So client A will listen. Okay, so client A will listen to the queue A. Okay, and whenever any message arrives, okay, let's say this message arrives into the queue A, it will just get transmitted through this WebSocket connection to the client B. To the client A. Okay. In the similar fashion, when any information or when any text message or anything arrives in the queue B, okay, it will get transferred to client B just like that. Okay, so this is the main purpose of the WebSocket. Okay, the WebSocket is just there to send message to the server and also listen the messages that is arriving in the queue. Okay, server is not sending message through the WebSocket, so the messages in the WebSocket that will flow in this direction. Okay, server to the client will come through the queue. Okay. Okay, so we have understood this. So W1 is listening to queue A and W2 is listening to queue B. Okay. Now what happens is, let's say client A wants to send a message to client B. Okay, client A wants to send a message to client B. So what happens is, let's say the message is hi. Okay, client A wants to send hi to message B to client B. So what will happen is, it will just send the message through the WebSocket connection to the server. Okay, now server will see. Now what the server will do is, server will have the message itself. Okay, so the message itself, or somehow we know that what is the whom to send this message to, and we can generate the routing information about the queue. So we can send the message to the server can send the message to the respective queue. Okay, how that is happening, that is pretty simple. You can there are many ways, but we are not going into that right now. Okay, so what happens is, server receives this message hi, and it sees, okay, I have to send this hi to client B. So what it will do is it will send the hi message. Okay, it will send the hi message into the queue B. Okay, so when the queue B receives hi in here, it will just get transferred into B, to the client B, as we know that there is an event listener happening. Okay, and there are stuff, so through the WebSocket W2, it will just get transferred to the client B. Okay, so this is the main process through which messages from client A to client B will get transferred. So let's say client B wants to send a message to client A. Okay, let's say hello, it wants to send hello to client A. So what will happen is, it will just send the message to the server. Then server will figure out, okay, I have to send this message to client A, so it will just put it inside the queue of client queue A. Okay, and the client A will be listening to queue A, it will get the message. Okay, in this fashion, everything is happening. Okay. Okay, so now so why I'm doing this, why I'm using this architecture or this design, and why I'm not using pure WebSockets, okay, without any queues or something. So the main problem that I had was, let's say there are multiple servers. Okay, there are multiple servers, let's say. Okay, these are the servers. Okay, this is server S1, this is S2, and then S3, S4, and so on. Okay, so on Sn. So I'm horizontally, when I will be horizontally scaling these this particular the servers. Okay, now let's say there are two clients, like previously, client A and there is client B. Okay, so now let us assume a scenario where there is no queues, we just have WebSockets. Okay, so when client A comes online or to the application, let us say it connects to S1 server S1, okay, through the WebSocket W1, and B connects to, let's say, S4, okay, through W2. Now let's say client A wants to send some message to client B. Okay, client A wants to send some message to client B. What happens is, it will send the message to this server S1. Now server S1 does not have any connection with client B. Okay, does not have any WebSocket connection. So server S1 cannot send any message to server B. Now this is a problem. Okay, so when you horizontally scale, finding out whether a client is online, if both the clients are not connected to the same server, it is pretty difficult to find out whether both the clients, or whether the receiver and the sender, one of them is online or not. We have to do many things to work around with that, but that I felt like is not a good solution. Okay, so now let us introduce queues into this picture. Okay, now we are introducing queues into this picture. So for client A, this is queue A, and for client B, this is queue B. Okay, now what happens is, let's say A is connected to S1 and B is connected to, let's say, Sn. Okay, B is connected to W2 and W1. Okay, it is listening to events in the A, and W2 is listening to events in B. Okay, now let's say client A wants to send something to client B. What it will do is, let's say it wants to send, please ignore the dog barking because it is night time and dogs bark right now. Okay, please ignore that. So let's say client A wants to send hi to client B. What it will do is, it will just it will just send hi to the server S1. Now server S1, as these queues are not tightly coupled with this with the servers, so every server has access, or like they can send some information into the queue. It doesn't matter if there are n servers or one server. Okay, it doesn't matter. Okay, any server can send any message to any queue. Okay, like if they have like proper credentials set up and all that thing. But yeah, okay, so now what happens is, like client A sends hi, that please send this hi message to client B. What the S1 will do is, it will just take the hi and put it inside the queue B. Okay, once the queue B receives hi, it will just get transferred to the through this W2 connection. Okay, it will just get transferred through this W2 connection into the queue B, and the client B receives the message. Okay, it is pretty simple. Okay, so in the same way, let me go with another example. So let's say B wants to send some message to client A. What it will do is, let's say this is the message. It will just transfer it to the SN server through this WebSocket connection W2. That please, SN server, please send this message to the client A. Now as SN gets the message, it will see, okay, I have to send this message to client A. Okay, so I'll have to find the queue A and just send it there. Okay, now SN or any server can send any message to any queue, so it will just take this text and just push inside the queue A. Once the queue A receives this message, it will get transferred to client A due to the like event listeners and through this W1 WebSocket connection. So that is how everything is happening in this text application. Okay, so this is the actual, like, the system design of the text messaging service. Okay, this is like, by using this architecture, I think that we can scale it pretty well. Now a question might arrive in your head that what if client B is offline? Okay, what if client B is offline? So in that scenario, what we are doing is, okay, so in case client B is offline, what we're doing is we have a temporary data store. Okay, I'm using a MongoDB. Okay, so this is a temporary data store, and what happens, let's say let's say A is online and B is offline. Okay, so when A connects, so it has the QA and everything is like set up. So A sends some information, let's say hi. A tells to the server S1 that please send hi to client B. Now S1 sees that, okay, there is no queue B in B that is awake right now. Okay, so what it will do is, it will just persist hi into this database. Okay, it will not actually store the actual message. So we are using RSA encryption to encrypt the messages. So in that way, like, to establish end-to-end encryption, we'll see that later on. So server will store this information inside the data store, and some information about the user. Okay, so like this is how the messages will be stored in the data store when client B is offline. Okay, it will store hi and let's say client B. Okay, so when client B comes online, it will connect to the the server. Okay, whenever it connects to this, it will generate his own queue, so the queue B, and when the WebSocket connection is established, okay, so let's say W2, when the WebSocket connection is established, what it will do is it will ask whether it received any message when it was offline. Okay, so it will go to the temporary data store and find whether there is any messages which has the user ID or like some unique information about him. Okay, so it finds that yeah, he has received a message called hi. Okay, so what the server will do is it will just take this message, remove it from here and put it inside the queue, and we know now what will happen after that. Okay, so this is how if the client is online, so we can transfer the messages without any problem. Okay, so this was about the messaging service. Okay, we have other services, so you can see from this picture. So we have other services like authentication service we have, okay, and we have profile services. So they're all working together to make the application look nice. Okay, so we have like RSA encryption to establish end-to-end encryption, and also to encrypt the messages so that like there cannot be a man in the middle attack or anyone in this server, or no one can basically read your messages until they just take your phone and run away. So that can be a scenario. Be aware about that. Okay, so let us start the application and see how things are. And you can also use the application. The source code is like pretty much open. You can install it and use it. So like you can go to my repository, then open up. Okay, this is the backend WebSocket RabbitMQ. I don't know why I chose this name, but I was just testing RabbitMQ with WebSocket. I did not find any resources online, so I was trying to test it, and then like it became the name of the application. But yeah, this is the backend and this is the front end. It is a React Native application, so you may try to use it. So let us switch on the application. So this is the, am I in the correct directory? No. Okay, so this is the Spring application. So to boot up, I'm just going to fire this query, and I also want to run this RabbitMQ. Okay, so I'm using Docker to run RabbitMQ. You can also install it, but this one is pretty easy. Using Docker, it's pretty easy. Now for the front end, let us start it. npm start and npm run Android. So okay, things are booting up. Okay, so things are up now. So as you can see, the application is up. Now let us see if there is any messages in the data store. So currently you can see there are no messages, and this is the RabbitMQ dashboard. You can see there are no queues yet. Okay, so no queues are created yet. So what I'm going to do is I'm going to log in with this ID 891, this ID. Okay, so I'm logging in. Okay, so these are the few users that I created while I was testing. So as you see, as I logged in, okay, a new queue is created whose name is same as the username. Okay, now this is another user like 983. Okay, so I want to text him something. So let me text him hi buddy. Okay, I'm texting him hi buddy. So he's offline right now. Okay, so as I texted him, and let me check in the data store. So as you see in the temporary data store, we have this message. It is in encrypted format, but yeah, it got stored in the temporary data store, and you can see it is sent by 891 and then it is sent to 983. Okay. Now let me log out of this account and log back in with the receiver's account. Okay, so now I'm logging in with this ID. So as you see, as I logged out, that queue which was previously created now is destroyed. Okay, so that shows that the user 891 is now like offline. Okay, so what we can do is now we can log in with this ID. So as I log in, you can see the queue will be created in a few seconds. Okay, you can see the queue is created and we got the message. See, we got the message, "Hi buddy," from 891 this account. Okay, you can see. So let me text him back. Hello 891. I am doing great. Okay, so I texted him. So now see in the data store, so in the temporary data store we have two messages. Okay, this is the first message, this is the second message. So it is sent by 98 and it is sent to 891. The second message also 98 and it is sent to 891. Okay, now again let me log out from here, then log in with the 891's ID. As I sign in, okay, I get the messages. You can see I get the messages, and in the database there are no messages now. Okay, so the messages are removed from here, and you get two messages from 9832's account. Okay, so you can see how things are working. So there are more features there, like you can change your profile picture, and I'm using AWS S3 to Amazon S3 to store the images, because it was pretty cheap and it was giving 5 GB free storage, so I use that. Okay, so that was all about it, and you can see, like as I logged in, a new queue is created with the same ID, and as I will log out, the queue will be destroyed. So you can see the queue will be destroyed in a few seconds. Okay, you see the queue is destroyed. Okay, so that was all about it for this video, and if you like the system design of my chatting application, or if you have any suggestions, then please comment down and let me know. So that was all about it. Thank you, goodbye, best of luck. Bye bye.